Copper. In the previous section, we examined inorganic contaminants such as asbestos and lead and how these substances may affect drinking water quality. Several other inorganic contaminants may also appear in drinking water and pose potential health risks to occupants of a property. One of the most common inorganic contaminants found in drinking water is copper. The primary source of copper contamination is the corrosion of copper pipes, plumbing fixtures, and household plumbing systems. Even when water leaving a municipal treatment facility meets federal and state drinking water standards, the water must still travel through miles of distribution pipes and the internal plumbing systems of homes and buildings. During this process, corrosion within pipes or fixtures may introduce copper into the water supply. Copper is considered an essential nutrient for the human body in small amounts, as it helps support various biological functions. However, when copper concentrations reach elevated levels in drinking water, it may lead to health problems. High levels of copper exposure have been associated with stomach and intestinal irritation, nausea, vomiting, and diarrhea. Long-term exposure to excessive copper may also contribute to liver damage, kidney damage, and anemia in severe cases. Because copper contamination is frequently related to plumbing corrosion rather than the original water source, properties with older plumbing systems may require additional evaluation or water testing. Mercury. Another inorganic contaminant of concern is mercury, which is known for its toxic effects on the human body. Mercury exposure has been associated with serious health problems, including kidney damage and kidney failure. Mercury contamination can occur through both natural and industrial sources. Many industrial processes historically used mercury in the manufacturing of products such as dry cell batteries, thermometers, fluorescent lighting, paint, dental materials, electrical switches, pesticides, and certain pharmaceutical products. Over time, mercury released from manufacturing activities can enter soil, rivers, lakes, and groundwater systems, eventually contaminating water environments. According to data cited by the Environmental Protection Agency, EPA, from 1987 through 1993, nearly 68,000 pounds of mercury were released into the environment, with approximately 90% of that amount entering land areas. These releases primarily originated from chemical and allied industrial operations. Some of the largest mercury releases historically occurred in states such as Tennessee and Louisiana, while direct releases into water systems were more commonly reported in West Virginia and Alabama. Although many industrial uses of mercury have been reduced or eliminated in modern environmental regulation, contamination may still occur in certain regions due to historical industrial activity. Because mercury is highly toxic even at low concentrations, monitoring and controlling mercury contamination remains an important part of environmental water safety programs. Nitrates. Another significant inorganic contaminant found in drinking water is nitrate, which commonly originates from agricultural and industrial activities. The Environmental Protection Agency, EPA, has identified fertilizers as one of the primary sources of nitrate contamination in groundwater and surface water systems. Fertilizers used in agricultural operations often contain nitrate compounds designed to promote plant growth. However, when these fertilizers are applied in large quantities, rainfall and irrigation runoff can carry nitrate compounds into nearby rivers, lakes, and underground aquifers. According to the Toxic Release Inventory, environmental releases of inorganic nitrates into land and water systems totaled more than 112 million pounds between 1991 and 1993. Significant nitrate releases during this time occurred in states with substantial agricultural activity, including Georgia and California. Two of the most common nitrate compounds that may contaminate drinking water include potassium nitrate and ammonium nitrate. Potassium nitrate is widely used in fertilizer production, as well as in manufacturing glass, ceramics, matches, and fireworks. Ammonium nitrate is also commonly used in fertilizers and certain industrial chemical products. When nitrate contamination enters drinking water supplies, it may create health concerns, particularly for infants and vulnerable populations. Elevated nitrate levels have been linked to conditions such as methemoglobinemia, sometimes referred to as blue baby syndrome, which interferes with the ability of blood to carry oxygen. Because nitrate contamination frequently originates from agricultural runoff, properties located near farming operations or agricultural areas may be more vulnerable to nitrate exposure. Inorganic contaminant removal. When inorganic contaminants are detected in drinking water at elevated levels, various treatment systems may be used to reduce or eliminate those contaminants. The environmental and water treatment industries have developed several technologies that can remove or reduce inorganic contaminants from water supplies. Common treatment methods include distillation systems, ion exchange systems, lime softening processes, and reverse osmosis filtration systems. Distillation systems operate by heating water until it evaporates and then condensing the purified vapor, leaving many contaminants behind. Ion exchange systems remove contaminants by exchanging ions in the water with harmless ions within the filtration system. Lime softening systems are often used by water treatment facilities to remove certain minerals and contaminants through chemical treatment processes. Reverse osmosis systems force water through specialized membranes designed to filter out contaminants at a molecular level. These treatment technologies may be used in municipal treatment plants or installed at residential properties to improve water quality. When to conduct a water test. When residential properties receive water from a municipal public water system, that water is regularly tested and monitored according to federal and state regulations. Public water providers must comply with strict drinking water standards and must regularly test for contaminants to ensure water quality meets regulatory requirements. However, the fact that municipal water systems conduct testing does not necessarily guarantee that water entering a home will always remain contaminant-free. Water quality issues can still occur if municipal treatment facilities experience operational problems or if contaminants enter the distribution system through aging infrastructure. Additionally, water can become contaminated after entering a property through corrosion in plumbing fixtures, pipes, and household water systems. Because of these potential risks, many professionals recommend that buyers conduct independent water testing when evaluating a property, particularly if there are concerns about water quality or plumbing conditions. A typical residential water test may evaluate several important factors, including coliform bacteria, nitrate levels, lead contamination, iron content, water hardness, pH levels, sulfate concentrations, total dissolved solids, TDS, and corrosion index levels. Additional testing parameters may be recommended depending on the location of the property and the presence of nearby agricultural, industrial, or environmental contamination sources. It is also important to understand that testing private wells is generally the responsibility of the property owner. In many transactions involving private wells, mortgage lenders may require water testing as part of the loan approval process. However, lender-required well testing may be limited in scope and may only include testing for bacterial contamination rather than a full water quality analysis. Because water quality can directly affect the health, safety, and long-term usability of a property, buyers are often encouraged to conduct comprehensive testing whenever there is uncertainty regarding the source or quality of the water supply. Online discussion: why can copper appear in drinking water even when the municipal water supply is tested and treated? Answer: copper often enters drinking water through corrosion of plumbing pipes and fixtures within the distribution system or within the home itself, rather than from the original water source. Why are nitrates commonly found in groundwater supplies near agricultural areas? Answer: fertilizers used in agriculture often contain nitrate compounds that can enter groundwater through runoff and soil infiltration after rainfall or irrigation. Why might buyers consider conducting independent water testing even when the property is served by a municipal water system? Answer: water can become contaminated through aging municipal infrastructure or through corrosion of plumbing systems within the property itself.